Hello everybody, welcome back to my channel, and today we'll be seeing how to reverse a linked list. But before I teach you how to reverse a linked list, let's see what does a linked list mean. So this entire thing is called as a node, and this node is like divided into two parts, which is one is the value and another one is called as the next. So basically next is nothing but it holds the address of the next index. So if you can see over here, there is 200 written, and 200 is the address of the next node. So that's pretty much it, the structure. Like, let me just simplify it even more. So it looks something like this. So here is the value and here is the next address, and this on its own also has its own address, and this entire thing is called as a node. So that's about a node in a linked list. So now in linked list, like there are multiple nodes which are connected to each other, and the starting of the node, like there is an address. So there's a head thing. There's a thing called as node. There's a node called as the head, which stores the address of the first node. So here you can see there is 100 written, which stores the address of the first node, which has its own address 100. So this is how a linked list looks. And now the question is, so let's just see how, so now let's just see on the computer how to define a structure of a linked list, and how to define a node, and how to do the simple operations like insertion in the beginning of a linked list and insertion at any point inside the linked list. So let's just go to the VS Code and see how does it look. So let's just start with how the normal C++ code looks like, which is hashtag include st hashtag include IO stream. Now using namespace std. Now int main. Now int main, and let's just put cout reports, and let's just see if this thing is working. Yeah, you can see navy codes has come. Okay, now let's just define a structure of a node for a linked list. So a linked list is basically a collection of multiple nodes. So let's just define a single structure of a node. So class, basically you can even call it a struct, but class is a bit better than struct, because class, like the concept of polymorphism and object-oriented programming comes in. So instead of struct, we are just using class. But yeah, so class node. Now this node consists of two values which I told. One is the data value and one is the next, which is the address of the next node. So I'll just put uh, int data, and also a thing called as next. And next, also one more thing which I have to say, what is next? Let me just go back to the iPad and to tell you. So now here you can see I've taken a node, and here is the, like the data or the value, and here is the next. Now this data is of type integer. Now what is this next? Like next is of which type? Like what is the data type of next? Like next is the address. So what is the data type of the address? So basically what we have seen is this is pointing to the next node, and node, so it is pointing to another element which is of a data type called as node. So if you go back to the, computer again, so the data type of next will be, is nothing but like how we type int data, right? Similarly, this the data type of, like the next will be, is nothing but node star next, and this is nothing but the structure of a node. That's it. Now let's go back to the computer and write node star, node star next, and that's pretty much it. And also, so let's just create a constructor so that these values will be initialized. So also there is one more thing. Constructor is nothing but constructor, and the name of the class is always the same. So now I'll just write node, and constructor is basically some sort of a function which initializes the the values which are being used inside the class. So if I just pass int value, and I just write data is equal to value, and the next is equal to null, and this is nothing but a constructor. So this pretty much it. And also one more thing, just put a semicolon over here so that the class is completely closed, and as present method. And also one more thing, you have to put a public over here so that these things can be utilized even in other classes and other functions. So your int main is a function and I want such things to be accessed even there, so I just put a public. So that's pretty much, this is the entire structure of a class. So let's just imagine, firstly, like we are inserting an element inside the linked list, and initially the linked list is empty. So at first the ll is empty, and when a linked list is empty, like firstly we need to define the head, right? So let's just make a head node star head, and now head is equal to new of head of 4. Suppose I want to insert an element called as 4, new node of 4. So I want to insert an element called as 4 inside the linked list, which is completely empty. And now let's just see if it is being uh, entered inside the linked list or not. So let's just type head dash the data, what data has been entered, and also let's just see what is the next value of the head. So next value is nothing but the next address of the head. It should be null because only one element has been entered inside the linked list, and after the first element being entered there is nothing, so it will be null. So cout head dash next and null. Now let's just run this entirely. So here you can see I have got as 4 because 4 is the element which I have entered inside the linked list, and only one element is being entered inside the linked list, and there's nothing else after the first element. So the next, the basically in null, it's calling 0x0 as null. So yeah, that's pretty much it. Now what if I want to enter elements from an array into a linked list? So your so let's just see. So this is the entire array which I. So what if we want to enter the elements from an array into a linked list? So let's just create an array for int I equals to 0, I less than 6, I plus plus. Now I want to enter all the elements of the array inside the linked list. So how do we do it? So the way how do we do it is, and this entire thing which I want to insert inside this will have its own address of like 200 or something. So let's just see how will I insert this inside the linked list. So now in order to insert a node inside the linked list, I'll be using another node which is of the name temp. So I'll just write node star temp is nothing but temp is nothing but a pointer which is of a data type of node. So node star temp, and now this temp I will put the value of this thing for temporary reasons, like for temporarily. Temp is equal to new of node of 40. So now a new box is being created which is called as the temp, and now this temp has the address of 200 which is of this thing, and this becomes null, and now I want this null to be pointing to this. And how do I get the address of this? Which is by using the head. So I will just equate temp to head. So let me just write temp next is equal to head. So this will make this null go away, and now it will become as 100, and this link will be made. And now I want to equate this head to this. I want to make my head over here. So I will just put head is equal to temp. So head is equal to temp, and this way my this thing will be broken and it will become like this. And you can just ignore this for now, and that's it. So this is the basic code of how to insert an element inside this. So let's just do. But there's also one more thing which you have to consider, is that there might be times where the linked list on its own is entirely empty. So there are two cases: either the linked list is being empty or the linked list consists of elements. So the thing which we saw over here was of the case where the linked list exists. So we have to do if and else thing. So let me just write the other half of the if and else. We go to the if part, then we check if head, we check if head is equal to null, that is like lel is empty, then we just directly put temp is equal to the head and call it a day. And if that is not the case, and if that is not the case and ll exists, so we'll just put as else, and that's it. So what we can do is we can just write a for loop for int I equals to 0, I less than array of size and I plus plus. We can just check if head is equal to null, then so it will become this array of I, and here also it will just become array of I. And this is how the code will look if we want to insert the elements from an array to a linked list. So let's just go into VS Code and see it more properly, and over there things will become more clear. So the first case is if ll not exists, so we just put if head equal to null, and if head is equal to null, then we just put head is equal to new node of array dot I. This will be like for this element, because we are actually first creating a linked list and putting inside it, and after the first element, which is like second, third, fourth, fifth, the array exists. So now it will go to the else part, and we have to create a temp variable. Sorry, we have to create a temp pointer which is of type node. So let's just do that. So node star temp. Now temp is equal to array new node of array I, and now temp's next should have the address of the first element, and the address of the first element is held by the head. So we just put temp dot, the next, I mean the address of the temp, like the next address of the temp should be equal to the head. So next is equal to head, and now the position of the head should be changed back to the temp. So head is equal to temp, and that's pretty much it, I guess. Let me just put this over here, and then exists, and over here we just put uh, printing the ll. So let's just create another temp node. My node is in capital, so okay, node star temp is equal to head, and now while temp not equal to null, I just see out, like I just print out the temp dot, what have I called it? I called it as data. So I just put data, and for looking more beautiful, I'll just put spaces between them, and this is it. And also temp is equal to temp dot next. So until the temp keeps on going forward from one node to the next node to the next node, until the temp doesn't reach to the lastmost where null, to the lastmost node which points to null, it will keep on be printing the data which is held by each node. So that's pretty much it, and I'll just remove maybe codes from here, and the code should run. I'll just remove this also so that it looks beautiful, and I'll remove this as well. So let's just run. So put equal to segmentation fault. Oh, and I'm getting a segmentation fault because I have to put head is equal to null, and now it should run. Yes. So the elements have been completely entered into the linked list. So this was everything about linked list, and we just saw how to insert the elements into a linked list. So thank you so much for watching the video. In the next video, we'll see how to find the middle of a linked list by using the normal method, and also we'll see how to find the middle of a linked list using the concept of slow and fast pointers. So thank you so much.